Here's what you'll see today. Wheat flour mixed with alkaline salts until it becomes elastic dough, giant rollers pressing it into endless sheets, precision cutters slicing it into delicate strands, steam chambers cooking each line, and drying systems sealing in shelf life and texture. Then, flavor packets and toppings are added before your noodle cup is sealed and ready for shipping. By the end of this video, you'll understand exactly how instant ramen is made in bulk, step by step. Before we move on, please take a moment to subscribe to the channel and like the video. Millions of noodles start not with seasoning packets or broth, but with a mix of 4 very ordinary ingredients: wheat flour, water, salt, and a special kind of alkaline salt. On the surface, it sounds simple, but this blend is what decides how the final noodles will look, feel, and even cook when you pour in hot water. Factories cannot leave this step to chance. Every batch must measure out exact amounts so the noodles turn out identical, whether it's the first packet of the day or the 10,000th. But there's more going on here than just mixing flour and water together. You might wonder, why add salt and alkaline components at all if you could just make a plain flour dough? The salt isn't there only for flavor. It plays a role in tightening the gluten so the dough has more strength. The alkaline salts are even more important. They are usually a blend of sodium carbonate and potassium carbonate, and without them, the noodles wouldn't have their bright yellow tint or their springy bite. These chemical salts even affect how the noodles behave later when they're cooked in boiling water after months on a store shelf. They help the noodles bounce back into shape instead of falling apart. Now picture the scale. While at home, you might stir together a few cups of flour in a bowl. A factory handles tons of it all at once. The ingredients drop into enormous steel mixers that can weigh as much as a delivery truck when full. Inside, giant paddles rotate slowly, folding and pressing the mixture until it starts to bind. From above, it looks like waves of dough rolling over themselves, each fold stretching the gluten little by little. Within minutes, thousands of pounds of flour are no longer a loose powder, but a strong and stretchy mass. The same job by hand would take hours, even with several people working non-stop. The mixing doesn't stop when the ingredients combine. The machines must knead the dough until it reaches a very specific consistency. Too stiff and it will crack when rolled. Too soft and it won't hold its shape. The automation here matters. Millions of servings are riding on one key detail: texture. If the first batch of dough is even slightly wrong, every noodle cut from it carries that flaw all the way to the package. Factories rely on sensors, timers, and careful checks to avoid that, because instant noodles only succeed if every strand feels the same to the bite. So at this stage, you're looking at what's basically the building block of instant ramen everywhere. Dough that stretches without breaking and holds together under the pressure of the next machines waiting down the line. The question now is how this single uniform sheet turns into millions of thin strands. All so exact, they could be mistaken for copies of one another. That step begins the moment the dough leaves the giant mixers and enters the rolling system that shapes it for cutting. How do giant sheets of elastic dough turn into the delicate strands you recognize in a ramen cup? The answer starts with machines that are built to handle speed and precision at the same time. Once the dough leaves those massive mixers, it doesn't head straight to packaging. Instead, it travels onto a conveyor system designed to roll it thinner and thinner until it reaches just the right thickness for cutting. This belt and roller system works much faster than any human could, and it makes sure every sheet comes out even. Without this step, the noodles would not cook the same way later. But here's the big question: how can factories make millions of noodles that all look exactly alike? The secret is layering and compressing. The dough isn't just flattened once. It passes through multiple rollers, with each pass making it thinner and more elastic. Sometimes sheets are stacked and pressed back together, which strengthens the gluten and gives the noodles their bounce. This repeated rolling and layering also ensures the surface is smooth across the sheet, removing tiny gaps that could cause uneven strands later. Once the dough is set at its ideal thinness, the next step happens with impressive accuracy. Sharp cutting blades, lined up in perfect rows, slice the sheet into strands. These blades are engineered so that the width of each noodle never changes, not at the start of the run and not at the end. In fact, the variation is so small that it can't be perceived by eye. That level of precision matters because the cook time of each noodle depends on its thickness. A noodle that is even slightly wider could take longer to soften when hot water is added. The scale is massive. Imagine a machine cutting thousands of feet of strands every minute, with each strand landing in neat bundles that look exactly the same as the ones before. This is how factories can produce millions of servings each day without any visible difference between packs. It is automation meeting consistency on a level that's hard to picture until you see the long ribbons forming in real time. Then comes one of the most important stages, steaming. As the strands move down the line, jets of steam surround them, raising the temperature high enough to partially cook the dough. This isn't for flavor, it's for structure. Steaming causes the starches in the flour to set and begins the process known as gelatinization, which locks in the chewiness. Without steaming, the noodles would be fragile and fall apart when later exposed to boiling water. Factories carefully monitor time and temperature here, so the strands are firm but flexible. This controlled steaming does much more than cook. It helps the noodles keep their shape when stored for months, while still springing back to life once water is added. With the strands now stable and elastic, they're ready for the next massive step, removing almost all of the water to guarantee both shelf life and safety. What ensures a brick of noodles can sit on a shelf for months but come alive in boiling water in just minutes? The secret lies in how factories remove nearly all of the water from each strand. This is where one of two big methods comes in: frying or hot air drying. Both achieve the same goal but in very different ways, and each method leaves its mark on the texture, taste, and even nutrition of the final product. Frying is the faster method and one that most people are likely familiar with. After steaming, the noodles are immersed in oil heated to extremely high temperatures. The strands only stay there for about 1 to 2 minutes, but that short bath changes them completely. The water inside the noodles evaporates almost instantly, leaving behind a dry and porous structure. Those tiny pores make fried noodles rehydrate quickly, which is why they can return to their springy form in just a few minutes of hot water. The flip side is that oil adds fat to the noodles, which affects their nutritional profile and raises calorie content. On the other hand, air drying skips the oil. Instead, factories move the noodles through tunnels where blasts of hot air slowly draw out the moisture. This process takes longer, but it avoids the extra fat found in fried varieties. Some air-dried instant noodles can have less than 1 gram of fat a serving, making them popular with people who want a leaner option. The result is a noodle that might take a little longer to soften in boiling water, but appeals to consumers who value a lower fat product. No matter which method is used, the key is controlling moisture down to a very small percentage. Fried noodles usually contain only 3 to 6% water by the time they leave the line. At that level, bacteria and mold cannot survive, which keeps the noodles safe at room temperature for months. Going too high risks spoilage. Going too low risks a crumbly texture that could break apart in the package. Factories walk a fine line here, balancing safety and texture with exact numbers. Once drying is complete, it's time for the flavors. Seasonings are prepared separately and packed in small sachets or pouches. Powders are measured out for dry blends like broth bases, while oils and pastes are sealed to lock in aromas. Keeping them separate prevents the seasonings from going stale while the noodles wait on store shelves. The two only come together when you open the packet and cook the noodles yourself. Every year, billions of meals depend on factories turning just flour, salt, and water into something people can eat within minutes. This isn't just food. It's the result of precision machines running day and night across the world. For example, in Japan, the average person eats nearly 50 packs of instant noodles each year, showing how large the demand really is. Meeting that need requires a system that can repeat the same steps millions of times without error. Instant ramen may seem ordinary, but behind every pack stands engineering, automation, and a journey from raw flour to noodles at the speed of hunger.